Again, let's see if we can't find the interval, not just a radius, but the interval of convergence. So, taking a peek at yet again an application of the ratio test. In absolute values, here is the n plus first term, neglecting that factor. Reciprocating by the absolute value of the nth term. Again, not looking at the factor. But when it comes to that factor, the component of the n plus first term divided by the component of the nth term involving it in absolute values does reduce down to a single absolute value factor of this. I will force this to be strictly less than 1, according to the ratio test. Now, again, remember, this does not involve n. You can treat it as being outside the limit. So let me massage this a little bit. Again, we're trying to solve for x in this inequality. Now, certainly this limit, it varies quite nicely. It is simply Euler's constant. However, when it comes to this limit, isn't this its behavior? So question, what values of real numbers can I stick in for x here so that this limit, which varies as such times it, and also times e, is strictly less than 1? Well, the answer is none of them. With one exception. I have to admit, going back to the original series, if x is equal to a, or in this case pi, then this becomes a 0. 0 times anything is 0, and the sum of 0 infinitely many times is still 0. I always have convergence at x equals a. So my radius may be 0, but I asked for the interval of convergence, and the interval of convergence is simply the singleton set containing a, which in this particular example is one of our favorite numbers.